So I want to talk about a concept in mathematics, and that's called this idea of being a prime number. So if we remember a number like 7, if we do the prime factorization, it's only made up of 1 and 7. So the number itself and 1 are its only factors that this number is divisible by. That means it's a prime number. Now, if I have two numbers, it's said that they can actually be relatively prime or coprime. And that satisfies one of these similar ideas. So let's say I have the number 17 and 35. Well, the factors of 17 are 1 and 17, and 35, 7 and 5. Now, neither of these numbers have any common factors between them. I have 1 and 17 here, 7 and 5 on this side. So if I was thinking about those as sets, if I label this as A and B, I might say A intersected with B equals the empty set. And since there's nothing common in between these numbers, I can say that they're relatively prime. Now, of course, 5 can be factored into 1 and 5, and 7, 1 and 7. You might argue that a 1 is here, but that's the definition, that there's no common factors other than 1 when I break these down to the prime numbers. Okay, so that's what it means to be a relatively prime number. The second way to look at it, if you aren't comfortable with the set notation, is performing the GCD of 35 and 17. If I was to solve this using our algorithm, so if I take 35 mod 17, what I get is I swap in the small guy here, 17. 17 goes into 35 twice. I get a remainder of 1. If I perform the same algorithm again, I notice that the GCD here is 1. Okay, so another way to look at it. Now if the GCD is something other than 1, say in this example, 75 and 25, where I factor these numbers out, 5 and 25, this is not relatively prime, 75 and 25. They share these common factors together. So that's an example of numbers that are not relatively prime or not coprime.